So today we will look at the heart of reptiles, right? So basically the circulation in the reptiles is incomplete. It is incomplete double circuit circulation, as we have seen in amphibian 2 that there was incomplete, right? So now let's look at the components, right? So first is we have two atriums, and two ventricle, right? So now let's come to the structure of the heart. Okay, this is basically the heart. This is right atrium, this is left atrium, this is right ventricle, this is left ventricle, right? Okay, this is quite looking quite messy. Let me clear this. Okay, so this is going towards the lungs. Let me draw it, then I'll be able to explain you guys. Okay, this is going to basically lungs, right? And this is basically systematic arc, right? So and over here, okay, so here we have the heart of the reptile. So let me explain you guys. Basically this is the right atrium, right? And this is the right ventricle, this is left atrium, this is left ventricle. Over here we have two arc which are basically going towards lungs for oxygenation. Then these are the systematic arc. As we know, the systematic arc is spread in whole body to provide oxygenated blood. Okay, so over here in the right ventricle we have cavum pulmonalis, and in the left ventricle we have cavum venosus. Let me write over here. CP means cavum pulmonalis and CV is known as cavum venosus, right? So over here what will happen, the deoxygenated blood, basically the deoxygenated blood will come into the right atrium, then it will go into the left ventricle, right? Then in after left ventricle it will move to the cavum pulmonalis, right? I'm talking over here about deoxygenated blood. As you know that deoxygenated blood is received by the right atrium, right atrium to right ventricle to uh, cavum pulmonalis, and then to this is basically known as, this is known as pulmonary trunk, right? It is known as pulmonary trunk. So right atrium to right ventricle to cavum pulmonalis to this known as pulmonary trunk, and from pulmonary trunk to the lungs. This deoxygenated blood will go for the oxygenation purpose, right? Now what will happen, like from the lungs to the right atrium, the oxygenated blood will come. Now this oxygenated blood will go to left ventricle, and after that, after left ventricle, it will move to cavum venosus, and after cavum venosus, it will move to the systematic arc. It will move to the systematic arc, and after systematic arc, it will move to the whole body. Like the systematic arc breaks down into, like it divides into, we have carotid arc, right? We have coronary arc, right? So let's summarize this. What will happen? The deoxygenated blood will come to right atrium to left atrium, left ventricle. Now left ventricle to cavum pulmonalis to pulmonary trunk, and pulmonary trunk to lungs. For what? For oxygenation, right? So this is a summary. Okay, now what will happen? The oxygenated blood will come in left atrium to left ventricle to cavum venosus to systematic arc, and it divides into the systematic arc basically divides into carotid arc, in coronary arc, and into many other, like it gives blood to the whole body. So this is the summary of heart circulation in the reptiles. And as in, okay, there's one more thing I forgot to tell you guys, that this interventricular septum, basically this interventricular septum is incomplete, right? This interventricular septum is incomplete. Interventricular septum is incomplete. How? Like as you can see over here, it is not completely made. It is not completely made. So what will happen here? Mixing of blood will take place. The blood will be mixed. So when the blood will come to left ventricle, before moving to cavum pulmonalis, there will be mixing. Right? And here, before moving to cavum venosus, there will be mixing. So let me summarize this again. What will happen? The deoxygenated blood will come to right atrium. Now from right atrium to right ventricle, and as we know that the interventricular septum means the layer between two ventricles, a layer which separates two ventricles is missing, right? And from other side, the oxygenated blood is coming from left atrium to left ventricle. Now the oxygenated blood from this left ventricle and the deoxygenated blood from the right atrium both will mix, and the mixing will take place. The mixing will take place. Now that mixed blood is carried from carried to cavum pulmonalis. Now cavum pulmonalis to pulmonary arc, and pulmonary arc to lungs for the oxygenation. And here this mixed blood is carried by cavum venosus. Now cavum venosus to the systematic arc, and systematic arc to the whole body. Basically there's mixing, but there's low amount of mixing, as we have seen in reptiles, sorry, in amphibians. There was high amount of mixing, like there was no such interventricular septum, right? But here we have, but which is incomplete. That is incomplete, right? So it means there will be low ratio, means there will be low ratio of mixing. Low ratio of mixing. So that's why this is known as incomplete double circulation, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I would be very glad to answer you guys.